The physics of failure. Why this world record jump was humanly impossible. The hook, the moment of impact. We love a hero. We love the person who defies the odds, breaks the record, and touches the sky. But gravity doesn't care about your dreams. Look at this frame. To the naked eye, it looks like a legendary attempt. But to a physicist, this is a crime scene in progress. From the moment he left the ramp, he wasn't a world record contender anymore. He was a projectile bound by laws he couldn't break. Today, we're deconstructing the jump that everyone thought was a freak accident. I'm going to show you why this wasn't just a failure. It was a mathematical certainty. This jump was humanly impossible, and the math proves it. The launch, the math of no return. Every world record attempt starts with a number. For this jump, that number was insert speed e. 110 km/h. But here's the problem, the margin of error. At this scale, if your launch angle is off by even 0.5 degrees, your landing point shifts by over 3 meters. Most people think he crashed because he got scared. Wrong. He crashed because of kinetic energy, $_k equals \frac 12 mv $2. When you double your speed, you don't double the danger, you quadruple it. He was carrying enough energy to shatter concrete, and his equipment was only rated for half of that. 3. The dead zone, mid-air instability. Once you're in the air, you're a passenger. This is where the dead zone happens. In a standard jump, you control your rotation using your limbs. It's the conservation of angular momentum. But at this height, wind resistance becomes a wall. At speed, the air isn't gas anymore. It acts like a liquid. His body began to pancake, increasing surface area and destroying his flight path. Physics had already decided his landing position while he was still 50 feet in the air. The biology, the G-force limit. Let's talk about the human machine. A human femur can withstand about 4,000 newtons of force. Sounds like a lot, right? But in this impossible jump, the calculated impact force was over 12,000 newtons. That's like having a small elephant step on your legs from a 10-story building. Even if he had landed perfectly, his bones were destined to fail. The human skeleton has a structural limit, and this record attempt asked for 300% more than what evolution provided. It wasn't a lack of skill, it was a lack of carbon fiber bones. The hubris. Why did they try? So why did the engineers let him go? Why did the math fail them? Because of the success bias. In the world of extreme sports, we've seen so many miracles that we started believing physics was optional. We looked at the highlights and ignored the variables. The silent night of this story wasn't the peace after the jump. It was the silence of the calculators that should have said no. The conclusion, respecting the laws. Why does analyzing this failure matter? Because understanding the physics of failure is how we achieve the next great success. We don't break the laws of physics. We learn to dance within them. This jump wasn't a tragedy of bad luck. It was a masterclass in the limits of the human form. Now, I want to hear from you. Do you think athletes should be allowed to attempt impossible math? Or is it too irresponsible? Which part of the physics, the speed, the drag, or the bone density, surprised you the most? Let's debate in the comments below. Hit that like button if you learned something new today. Subscribe for more deep dives into the science of the world's most extreme moments. Next week, we're looking at the engineering of the Titanic II and why it might be destined for the same fate as the first. Thanks for watching. Respect the laws of nature, and I'll see you in the next one.